Okay, so I'm just going to go through these examples really quick. And again, the more you do these, the more that you should be able to recognize the situations. All right, the first one, you can quickly identify that as being ionic because it's got sodium as a metal. All right, so with these, all you have to do is give a first name. All right, that's sodium, and the last name is going to be sulfide. All right, IDE. That's a monatomic ion. That's why it ends in "ide." All right. It's not, sodium is not one of the transition metals, so it does not need a Roman numeral. All right. Notice that there are no prefixes because it's ionic, and you don't do that with those. All right. The second one, this is ionic. And again, with ionic compounds, you can always separate the positive from the negative. All right. So that line would be here for this compound at the top. For this one, it's going to be here. All right. That right there is ammonium. That's a polyatomic ion. That second thing is just a chloride ion. All right, so this is ammonium chloride. All right, this next one is, again, this is ionic because there's a metal. All right, I can separate. It's pretty easy if it's ionic and there's only two elements. So the line's got to be, there's only one place for the line. And this is one thing that we want to make note of is that that is a transition metal. So that means we're going to need a Roman numeral. All right, so copper, fluoride, and a way to do this, there's only one of those things right there, and it's got a -1 charge. That's got to be balanced by a +1 charge. And there's only one atom in there. There's only one copper atom, so it's going to come up with that entire charge. So that means it's got to be a +1 charge, and that's because that's what is needed to balance the -1 charge of this fluorine atom. All right, so that's copper 1 fluoride. All right, and again, that Roman numeral 1 comes from the charge. All right, this one is similar. I'll go ahead and do this one as the seesaw, which is just the same thing that I'm doing in this region up here. All right, so you've got 2 of those fluoride ions. That's a total of 2. So that's got to be balanced by a +2. So that's a -2 on this side, balanced by a +2. And there's only one copper atom in this formula to do that. So that means it's got to have a +2 charge. All right. So this one right here, again, let's take a look at this. This is ionic, all right? And remember, with ionic compounds, we should be able to draw a line that separates the positive stuff from the negative stuff. Here, that line is going to be right here. All right, so the positive thing is a lead atom. The negative thing is actually a polyatomic ion. That is sulfate. All right, and lead is a transition metal, or at least it behaves like one, which means it's going to need a Roman numeral. All right, so if I were to do this, this is going to have the negative thing is a sulfate ion. All right, and it has a -2 charge. And again, you can find that from the list in the reference guide. And you know, sometimes people have asked me, how do I know there's just one sulfate in that? All right, I don't see a 1 anywhere. And one way that it helps is if you were to think about it, if I drew it this way. All right, this shows, the way I drew it like this, it shows that there's only one of that sulfate group. But remember, when we simplify that, we take the 1 out, and when we have just one of a polyatomic ion, we take away the parentheses. So that's why it looks like this. So when you're looking at this, recognize there's only one of that sulfate. So that's going to be a total of -2 balanced by a +2, and you've only got one lead atom, so that makes that +2. So lead, Roman numeral 2, sulfate. All right, and make sure you get that part right, because it's, if you put sulfide, it's not the same thing as what we're looking at right here. All right, so this next one right here, that is, a lot of times it's when you have more than one polyatomic ion, it's kind of a giveaway because it's the only thing that we put in parentheses in a formula. All right, so that means that the divide is right there. That is mercury, which is a transition metal, which means I'm going to need a Roman numeral. All right, and this thing right here, that is nitrate. You find that in your guide. All right, so the name is going to be mercury. All right, I know that I'm going to leave some space for a Roman numeral because this guy it needs a Roman numeral, and its last name is nitrate. All right, which I get from looking up NO3 in the reference guide. And one thing that I could, if I did the little seesaw thing, we've got nitrate, which is like this, but in this formula we have two of them. All right, so that makes a grand total of -2. All right, so that total -2 charge has got to be balanced by a +2, and there's only one mercury atom in this formula, so it's got to pay the whole bill. So that means that it is mercury 2 nitrate. All right, this one right here. Aluminum is one of those atoms that you just have to memorize its charge. It's not one that requires Roman numerals. All right, so aluminum. All right, it does not need Roman numerals because and the reason we don't need the Roman numeral is that we already know, what its charge is. All right, it only comes in one variety, which is +3, and the last one is oxide. All right, this one right here, this is covalent. All right, it's covalent because these are all nonmetals. Okay, and the beginning is not ammonium. So remember, ammonium, that NH4, is the one way that you can have an ionic compound, but having all nonmetals. But since it's not that, it's covalent. All right, which means we need prefixes. All right, so therefore this is going to be dinitrogen tetroxide. All right, this one right here is going to be, again, this is ionic because I see a metal right there. All right, and that means if it's ionic, I can find a place that separates the positive from the negative. It's pretty straightforward here. This guy's name is potassium sulfide. All right, and remember IDE because this is sulfur by itself as an ion, as opposed to this compound right here, which was sulfate, which is sulfur, which is bound up in a polyatomic ion with some oxygen atoms. All right. The last one right here is this is got a metal, so this is ionic. So anytime you have an ionic compound, you should be able to separate the sides. The sides are that's where the separation would be. The first name is sodium. All right, and sodium's not a transition metal, so we don't need Roman numerals. And then what's the last name? I can see this is definitely going to be a polyatomic ion. And what is the name of ClO2? That is chlorite. All right. Okay, so on these, we're going the other way. So this first one, I can already tell it's ionic because it's got a metal right there. And when it's ionic, I know I'm going to have to do the crisscross rule. All right, so nickel. All right, what's the charge? All right, well, the Roman numeral tells me what the charge is because it comes in two different varieties. That's why we need the Roman numeral. chloride, we know because of its position on the periodic table, we crisscross these guys, and I get Ni1Cl2, which simplifies to NiCl2. All right, copper 1 nitrate. Again, it's going to be very similar to the one above. We have copper, which has a plus one charge from the Roman numeral. And then we have nitrate. And in this case, we are going to just find that by that is again, this is an 8, which means it's a polyatomic ion. We find its formula from the reference guide. Again, my advice is to put the atoms inside parentheses with the charge on the outside. And we're going to crisscross, which would give us Cu parenthesis NO3 1. All right, but then we see that there's only one of these polyatomic ions, so drop the 1 and drop the parentheses, CuNO3. All right, ammonium sulfate. All right, these are ammonium tells us that's an ionic compound. All right, so so we know we're gonna have to do the crisscross rule. We can get the formula for ammonium from the reference guide. Sulfate is also a polyatomic ion. All right, you know that 8 right there should give it away that you're going to have to look at this right here. That's got a -2 charge. We're going to crisscross these, and what we initially get is NH4 2 parentheses SO4 1. All right, check out your ratios, which are 2 to 1. That's a fully simplified ratio, but we know that we can take out the 1 in the parentheses. All right, but you need the parentheses around the NH4 because there's 2 of them. All right, and so I've been asked, is it okay if I leave the 1 in there? And for this, you'd need to take it out. All right, people would never leave that in there. All right, magnesium nitride, Mg+2. Nitride is this. We crisscross those. We get Mg3N2. All right, mercury 1 sulfide, Hg. All right, this is an ionic compound. So mercury is a metal. It's +1. Sulfide is so IDE, which means monatomic. Do that. Crisscross. Hg2S. All right. All right. And you would be S1, but then we drop the 1. All right. Carbon monoxide. Covalent. There's 2 ways that we could tell it's covalent. First of all, both carbon and oxygen are nonmetals. And the second thing is it's got a prefix, which gives away that it's covalent. All right. So the way to come up with the formula is just use the prefixes. All right. Mono means 1. If I don't see anything in front of the first thing, that also means 1. So it's plain old CO. All right. Iron 2 oxide, Fe+3, oxygen -2. All right, to crisscross those, I get Fe2O3. A 2 to 3 ratio is fully simplified. This is covalent, which means take a look at the prefixes. Phos versus P, 2 of those. 5 of the oxygens. Calcium sulfate. Calcium is +2. Sulfate is -2. Crisscross those, I get Ca2SO4 2, and a 2 to 2 ratio is the same thing as 1 to 1. So this is going to simplify to CaSO4. All right, last one on this worksheet, sulfur dioxide, covalent, because they're both nonmetals. Sulfur dioxide. Okay. That's it. I'll try to get the one for the other worksheet in just a second.